Medicine has always been about repairing the body. We set broken bones, we fight infections. Now, we are entering a new era. Biomedical engineering is giving us the power to rebuild the body at its most fundamental level. This is the promise of tissue engineering and organ regeneration. These technologies offer hope for patients with organ failure, severe burns, and other debilitating conditions. For centuries, organ transplantation has been the only option for patients with end-stage organ failure. However, the demand for organs far outweighs the supply. This shortage leads to long waiting lists and, sadly, many deaths. Tissue engineering offers a potential solution. Scientists are working to grow new organs in the lab. These organs could be used for transplantation. The field of tissue engineering is rapidly evolving. It holds immense potential to transform healthcare. Imagine a world where organ failure is no longer a death sentence.
Tissue engineering is a complex process. It involves carefully orchestrated steps to create functional tissues and organs. The first step is the creation of a scaffold. This scaffold provides structural support for the cells. It guides their growth and organization. Scaffolds can be made from a variety of materials. These materials can be natural or synthetic. The choice of material depends on the specific tissue being engineered. Important factors include the mechanical properties and biocompatibility of the material. Once the scaffold is created, it is seeded with cells. These cells are carefully chosen based on the type of tissue being engineered. The cells may be harvested from the patient's own body. This reduces the risk of rejection. In other cases, stem cells may be used. Stem cells have the remarkable ability to differentiate into various cell types. After seeding the scaffold with cells, it is placed in a bioreactor. This controlled environment provides the necessary nutrients, oxygen, and growth factors. The bioreactor also mimics the mechanical and biochemical cues found in the body. By carefully controlling every step of the process, scientists can guide the formation of complex tissues and organs.
The ultimate goal of tissue engineering is to create fully functional organs. These organs could be used for transplantation. This would alleviate the shortage of donor organs. Bioengineered organs could also be used for drug testing. They could even be used to study disease processes in a more controlled environment. Scientists have already made significant progress in bioengineering organs. Researchers have successfully engineered skin, cartilage, and bladders. These tissues have been implanted in patients with promising results. However, engineering more complex organs like the heart, liver, and kidneys remains a challenge. One promising approach to bioengineering organs is decellularization. This technique involves removing the cells from a donor organ. This leaves behind a scaffold made of the organ's natural extracellular matrix. This scaffold can then be repopulated with the patient's own cells. Another approach is 3D bioprinting, which involves using a specialized printer to deposit layers of cells and biomaterials. The field of bioengineered organs is rapidly evolving.
3D bioprinting is a cutting-edge technology. It is captivating the imaginations of scientists and the public alike. This technology has the potential to revolutionize healthcare. It allows us to create living tissues and organs with remarkable precision. 3D bioprinting works by depositing layers of bioink onto a scaffold. This bioink contains living cells and biomaterials. The process begins with a digital model of the desired organ. This model is then fed into a 3D bioprinter. The printer uses this model to guide the deposition of bioink. The bioink is carefully extruded through a nozzle. It is layered in a precise pattern. This creates a three-dimensional structure that mimics the architecture of the real organ. One of the key advantages of 3D bioprinting is its ability to create complex structures. These structures would be difficult or impossible to create using traditional tissue engineering techniques. 3D bioprinting allows for the creation of intricate vascular networks. Another advantage of 3D bioprinting is its speed. This technology can create tissues and organs much faster than traditional methods.
Section 5. Stem cells. The seeds of regeneration. Stem cells are remarkable cells. They have the unique ability to differentiate into various cell types. This makes them an invaluable tool in tissue engineering and regenerative medicine. Stem cells can be derived from a variety of sources. These include embryos, adult tissues, and even reprogrammed adult cells known as induced pluripotent stem cells, or iPSCs. Embryonic stem cells are derived from early-stage embryos. They have the potential to differentiate into any cell type in the body. This makes them incredibly versatile for tissue engineering applications. However, the use of embryonic stem cells is ethically controversial. Adult stem cells are found in various tissues throughout the body. They are responsible for tissue repair and regeneration. While adult stem cells have a more limited differentiation potential compared to embryonic stem cells, they offer a less ethically contentious source for regenerative medicine. Induced pluripotent stem cells, iPSCs, are created by reprogramming adult cells. This reprogramming process reverts the adult cells back to a stem cell-like state. iPSCs have the potential to differentiate into various cell types.
Section 6. Clinical Triumphs. Tissue Engineering in Action. Tissue engineering and regenerative medicine are already having a real-world impact. Scientists and clinicians are making significant strides in applying these technologies to treat patients. From skin grafts to cartilage repair, the field is witnessing remarkable clinical successes. One of the earliest and most successful applications of tissue engineering is in the field of skin grafting. Skin grafts are used to treat patients with severe burns, chronic wounds, and other skin defects. Traditionally, skin grafts were harvested from the patient's own body. This is a painful procedure. It can lead to scarring. Tissue engineering offers a less invasive and more effective alternative. Scientists can now grow sheets of skin in the lab using the patient's own cells. These bioengineered skin grafts can be custom-made to fit the patient's wound. This reduces the risk of rejection. It promotes faster healing. Another area where tissue engineering is making significant progress is in cartilage repair. Cartilage is a tough, flexible tissue. It covers the ends of bones in joints. It acts as a shock absorber. Cartilage damage is common. It can lead to pain, stiffness, and reduced mobility.
The future of tissue engineering and regenerative medicine is brimming with possibilities. As scientists continue to push the boundaries of these fields, we can envision a future where organ failure is a thing of the past, where damaged tissues can be regenerated with ease. One exciting area of research is the development of bioartificial organs. These organs are hybrid systems. They combine living cells with synthetic materials. This creates fully functional organs that can be implanted into the body. Scientists are working on bioartificial hearts, livers, kidneys, and more. Another promising avenue is the use of nanotechnology in regenerative medicine. Nanomaterials have unique properties. These properties can be harnessed to deliver drugs. They can also be used to stimulate tissue regeneration. For example, researchers are developing nanoparticles that can deliver growth factors directly to damaged tissues. Advances in 3D bioprinting are also opening up new possibilities for creating complex tissues and organs. The convergence of these cutting-edge technologies is paving the way for a future where regenerative medicine plays a central role in healthcare.
As with any transformative technology, tissue engineering and regenerative medicine raise a number of ethical considerations. It is essential that we carefully consider these issues. This will ensure that these technologies are used responsibly and for the benefit of all. One of the most pressing ethical concerns is the use of embryonic stem cells. Embryonic stem cells have the potential to differentiate into any cell type in the body. This makes them incredibly valuable for regenerative medicine. However, the derivation of embryonic stem cells involves the destruction of human embryos. This raises significant ethical and moral dilemmas. Another ethical consideration is the potential for these technologies to exacerbate existing health disparities. Tissue engineering and regenerative medicine are complex and expensive procedures.
Despite the tremendous progress made in tissue engineering and regenerative medicine, several challenges remain. These challenges must be addressed before these technologies can be fully realized and made widely available. One of the biggest challenges is the complexity of the human body. Engineering tissues and organs that can seamlessly integrate with the body's intricate network of cells, tissues and organs is a daunting task. The immune system also poses a significant challenge. It can recognize engineered tissues as foreign and mount an immune response. This can lead to rejection of the implanted tissue or organ. Another challenge is the cost and scalability of these technologies. Tissue engineering and regenerative medicine procedures are currently very expensive. This makes them inaccessible to many patients. Scaling up production to meet the needs of a large patient population is also a major hurdle. The field of tissue engineering and regenerative medicine holds immense promise for the future of healthcare. These technologies have the potential to revolutionize the way we treat a wide range of diseases and injuries. They offer hope to millions of patients worldwide. Imagine a world where organ transplantation is no longer limited by the shortage of donor organs. Imagine a world where damaged tissues can be regenerated with ease. Imagine a world where age-related diseases are a thing of the past. This is the promise of regenerative medicine. While challenges remain, the rapid pace of progress in the field is encouraging. With continued research, innovation and collaboration, we can overcome these challenges and unlock the full potential of these transformative technologies. The journey towards a healthier tomorrow will require a collective effort from scientists, engineers, clinicians, ethicists, policymakers and the public. By working together, we can create a future where everyone has the opportunity to live longer, healthier and more fulfilling lives. The promise of regenerative medicine is within our grasp, and it is up to us to make this vision a reality.